Welcome back, everybody. Thanks for gathering around the telescope with me for our fourth article in the Astro News Roundup for January 29th, 2026. Right at the end of the month. First month done in 2026 this weekend. Can't believe it. Uh, this is awesome. I posted yesterday about Supernova and I found this article and just had to share it. It's exciting. I have a link to the article there. But it's been since 1604 since we've seen a visual supernova from our own Milky Way galaxy. We're about to be able to detect even more supernova, especially those that occur here in the Milky Way galaxy. And we're going to do it using the Vera C. Rubin Observatory. I know we're all itching to see one. I'm itching. I'm hoping before I leave this Earth life, maybe perhaps we'll have one and I can get to see it. But we're all waiting to see that next supernova, especially here from the Milky Way. I've seen multiple ones out in other galaxies, but I really would like to see one kind of close. Not too close, but close. It's the kind of explosion that used to light up the sky in ancient times, but we, like I said, haven't actually seen one since 1604 here on Earth. Well, the Vera C. Rubin Observatory is about to give us a front row seat to these cosmic fireworks. It's like being right at a 4th of July celebration with the fireworks going off above you. It's awesome. So Rubin, just so you know, isn't your typical telescope. It's got this huge field of view and rapid snapshot capability that lets it sweep the entire southern sky every few nights with incredible sensitivity. That means it doesn't just take a beautiful deep image of distant galaxies. It's perfect for catching things that suddenly brighten, like a supernova, right when they flare up. Now here's the cool part. When a massive star collapses, like we talked about yesterday in that post, in a core collapsing supernova, a type 2 supernova, it doesn't just give off light. As it collapses, it floods the universe with neutrinos long before the visible flash arrives. As the core is collapsing, those neutrinos are going out far before the explosion happens. These ghostly particles stream out instantly, and our neutrino detectors on Earth, and we have them, can pick up that burst minutes to days ahead of the light show going off. Rubin can then swing into action, scanning huge swathes of the sky to localize the optical explosion very quickly once the neutrino alert goes out. So the neutrinos will come, they'll hit the monitors, they'll send out a neutrino alert. Vera C. Rubin can then just get to that portion of the sky, and we can probably see the initial explosion pretty quickly. Simulations with hundreds of thousands of fake supernovas sprinkled throughout our galaxy show just how powerful this combo could be. Rubin has roughly a 57 to 97% chance of actually catching the next Milky Way core collapse supernova during its 10-year legacy survey of space and time. And sometimes a single 30-second exposure in its reddest form and its reddest filters could be enough to spot the initial optical light coming from the next supernova. There's challenges, like how do we handle dense star fields in the galactic plane, and when to switch filters to maximize your chances once the alert comes. But what this work lays out is a practical roadmap for how Rubin and neutrinos could give us the first real-time view of a core collapse supernova in our own galaxy. Awesome! So in other words, Rubin might just be the telescope that finally gives us the real-time show of a galactic supernova, the kind of event that will have backyard astronomers, amateur astronomers and observers and sky watchers, and professional astronomers alike glued to their screens and their telescopes when it happens, to see if they can see it for themselves. That's awesome. I look forward to that. What an exciting time to live in. Anyway, I hope you have clear skies. I do. Went out and looked up for a while tonight. Beautiful waxing gibbous moon. Jupiter's gorgeous up there. Orion was gorgeous. We had a storm come through yesterday. If the moon wasn't so bright, it'd be a night of night to observe. Still might try to get out and see Jupiter. Anyway, I hope you have clear skies. I hope you look up. Even if you don't have a telescope, even if you don't have binoculars, just go outside and look up and be amazed at what's up there. Anyway, we'll catch you next time. Have a great one.